our products are one of the best in the market, and we are always trying by all means to make sure that we bring you the latest on any developments that happen in our line of products. Okay, so far we've talked about quite a number. We've talked about the CX range. We've spoken about some accessories that you can use with the systems. We've spoken about the iSolar Cloud platform that you guys can use as a monitoring platform for all your installed system. All right, and there are those people who would want to use hybrid inverters. We've been speaking mostly about grid-tied inverters. So today we're going to be looking at hybrid inverters. Our hybrid inverters come in two formats. We've got three-phase and single-phase inverters. All right. So I'll start by showing you a video, a very short video on how to install a Tenarity, and then we'll get into detail of the Tenarity and the 6RS to see how best you guys can take advantage of their very nice features and their very useful functions. All right, so let's get right into it. All right. That was the video on the installation of our hybrid inverters, and that is a brief introduction to what you require and how to go about installing it. And now we are going to get into some detail for you guys to see exactly the features of this inverter and what you can benefit from the inverter. Okay, so all right, can you guys see my screen?
Yes, we can, Eden. Thank you.
All right, so this is in this training we're going to be looking at the Tenarity and the 6RS. All right, those are the two inverters in terms of the looks and pictures, right? The one on your left is the 10, sorry, it was an error there. It's called the 10RT, not 10RS. It's a three-phase inverter, and the 6RS on the right is a single-phase inverter, okay? Right, so the left one is the 10 kilowatts, it's a three-phase. The right one is a 6 kilowatt and it's a single phase, but they are both hybrid inverters. So here is the explanation of the code names. SH simply represents Sungrow hybrid, okay? We simply mean Sungrow hybrid by SH. Then the 10 or the 6 represents the power, all right? That's the power, okay? And then R means residential. R means residential. And then T means it's a three-phase. And then S means it's a single phase. That's how simple it is. SH means Sungrow hybrid. 10 or 6 represents the size of the kilowatts produced. And then R represents residential, T represents three-phase, S represents single phase. That is the code name for those inverters. So by simply looking at that, there's enough detail that you can get from that. All right, so here I've got some important parameters for the Tenarity. This data sheet covers from 5RT to 10RT, but we're going to focus on the 10RT because that's the one that we sell. Okay, so this 10RT allows a maximum PV input power of about 15,000 watts. So your panels can only go as far as 15,000 watts. In other words, this simply means that it can take a DC to AC ratio of about 1.5, which is quite good. And if you check the voltage, the maximum input voltage is 1000, which is more or less the same as the CX range that we did last week. It's quite a very good number, which can allow you to put as many panels as possible. It has got two MPPTs, and there's two inputs per MPPT. As you can see here, there's two inputs per MPPT. All right, and it can take a maximum input current of about 25 amps with 12.5 on each input. All right. The nominal output power is 10,000 watts, is the code name already says. And so this is very important, very important for us to see that. Especially what I like the most about this is this part, the maximum input power, which allows you to go as far as 1.5 DC to AC ratio, unlike most inverters which normally end at around 1.2 or 1.3. Okay, so that's the Tenarity in terms of its parameters there. Then the 6RS, this one here right at the end there, it can take about 13,000 watts peak or 13 kilowatts peak. The input range of the maximum input voltage is a bit lower than the 10. It's about 600 volts. Okay, it has got two MPPTs, and your output your input current that you're allowed to supply is 32. That is 16 amps per input. All right. This one also is when you're looking at it, if you look at the DC to AC ratio, it's very close to 2, right? Which is a decent figure when you are doing your installation. It's very, very good. It can take other huge numbers of panels, although your limitation will be on the voltage and also on the current. So that's a huge plus there. All right. So both so in this presentation, the way I'm going to present it is that there are situations where the features are the same, both in the Tenarity and in the 6RS. Then there are situations where certain features apply exclusively to one of the two, right? So I'll mention to tell you that this only applies to the Tenarity, this only applies to the 6RS. So this part here applies to both of them, right? We call it the PV energy storage system, whereby you have got your PV panels, your PV panels that are connected to the inverter B. Your inverter can be a Tenarity or it can be a 6RS there. And then C, that is your energy meter. If you are using a Tenarity, it's a 3-phase energy meter. If you are using a 6RS, it's a single-phase energy meter. All right. So the single phase or the 3-phase smart meter there on C actually communicates with the inverter via the RS485 port, which we remember that it's via A2B2 on the inverter. All right, and then D is your grid, that is your ESCOM, and then E, that is your storage, your battery. You remember we did the SBR batteries. You can also use LG Chem batteries. They also work with that inverter, right? And then F, that is your critical loads, and G, that is the rest of your other loads which are not on the backup. Okay, so this setup applies to both the Tenarity and the 6RS. The only difference is that the energy meter, if you are using an energy meter, remember the Tenarity is a 3-phase, so it uses a 3-phase meter. The 6RS is a single phase, so it uses a single phase meter. That is the only difference there. Right. Then we look at the energy management specifically for the Tenarity. There are situations where you want to manage your energy during the day and also at night. So let's start with the daytime management. We've got two scenarios during the day, right? So first of all, you might have a scenario one, whereby the power generated is greater than or equal to load consumption. Okay, you're producing just enough or just above what you are consuming. So firstly, what will happen is the PV power will go to backup loads first. When we say backup loads, we're talking about these ones here. It will go to your backup loads first, then normal loads, and then to the battery. So it will prioritize these, right? And then secondly, your normal loads, and lastly, it will charge the battery. So if you are not producing enough to supply those three points at any given moment, the priority will be the loads, the backup loads first, then the normal loads, and then the battery. Okay. Moreover, if the battery is fully charged, in other words, you don't need to supply any more power to the battery. That excess power will then go to the grid. That is why here you see a bidirectional flow of power between the meter and the grid, meaning to say you can get power from the grid or you can send power to the grid. And the feed-in power will not surpass the feed-in limitation. And remember, you have to put in settings in the inverter to say what is the maximum feed-in value that you can have on that inverter. The second scenario is whereby your power generation is less than the load power consumption. In other words, we are producing less power than what you are consuming. In this situation, what will happen is your battery will start to discharge and compensate for the gap in the power produced. All right, so your battery will be working in a scenario whereby your power generation is less than your power consumption. Again, your inverter will also draw power from the mains, which is from your grid. If the PV and battery do not produce enough power. So if your PV and battery's combined power is less than what is required, your inverter will start to take some of the power from the grid. Okay, so that's a very good kind of arrangement there, whereby your inverter can sense what is happening. If you're producing less than what you are using, the inverter will consider all three options: your battery, your panels, and your grid. If you're producing more than what you're using, your inverter will prioritize loads, backup loads, followed by normal loads, and lastly, charging the battery. Okay. Then during the night, what will happen is we are assuming that you've got energy available in the battery. So the battery will discharge to supply power to your loads. All right. Or else the grid will supply power to the loads if the battery is not supplying enough power. Right, so here you can see this gray line there between the panel and the inverter shows that there's no current flowing. Right, but what is happening is our battery is supplying power to the inverter and then to the backup loads. Right, the grid on the other side is also bringing in power if our battery is not producing enough power for all our loads. Right, so the grid will only come in if the battery power is not enough. As long as it's still enough, the grid does not need to come to the party. All right, so we've seen both scenarios there, that you can actually have a very flexible situation whereby your system can adapt to anything, depending on whether you're producing enough or more than enough, or you're producing less, or you are not producing anything at all from your panels. That will be sorted by your inverter. So it's a very intelligent algorithm that it uses, that it checks all power sources to make sure that there's coordination and chooses which one is most appropriate at any given moment. Right. You might also find out that your battery is now empty. So this situation that we've just spoken about is a situation where your battery has got power. That's why it has a blue line getting into the inverter, showing that there's current flowing. In the event that there's no more current, in other words, your battery is now empty, your inverter will go into standby mode, right? Because there's no power that is coming from the panels, there's no power coming from your battery. Then it will switch on the grid to supply everything, your backup loads and also your normal loads. All right. So there's quite a number of scenarios as we have seen. We've seen a scenario whereby we're producing more than we use, or a scenario where we produce less than we use during the day, or a scenario whereby we have enough power stored in the battery, or a scenario where our battery is empty. So all those scenarios, our system is very flexible to be able to supply you with power and also make sure you're not left in the dark. Right. So, like most inverters that we've been talking about, even the CX range, your Tenarities can be paralleled. Okay. You have a maximum of 5 inverters that can be put in a parallel system. The assumption is that they are all the same size. So if it's 10RT, it has to be 10RT. If it's 6RS, it has to be 6RS. You shouldn't, we recommend that you don't mix these things, right? Because remember, communication protocols differ, and also monitoring itself becomes a nightmare if you have got Sungrow linked to SunSync or some other brand. It becomes a nightmare. Of course, if it's a you can't use a 10RT and a 6RS in the same system, because one is single phase and the other is 3-phase. So here we're assuming that if it's three phase, you're using the 10RT, you can put them up to 5. Right? If it's a 6RS, you can still do the same. They all have to be same size. Right? So this system can operate both in on-grid and off-grid modes. As you can see here, each inverter A, B, C up to whatever point up to F, they all each have its own string of panels and each on storage and loads as well. Okay, so each inverter is connected to its string of panels and its energy storage system, right? But all of them are then linked to one 3-phase meter there that then goes to the grid. So as you can see, inverter A is the master. B and C are slaves, slave 1 and slave 2 respectively. And then your D is the connection that comes from the grid. All of them, all the inverters need a grid connection, just in case the storage runs out, okay? Or you're not producing enough from your storage and also from your PV panel. So you need this line D that will connect all your inverters to a common line of the grid. And then E, those are the backup loads. These are the backup loads that you connect to the backup port on each inverter. And then F, it's the RS485. That is the actual connection that links one inverter to the next. Remember, port A1, B1, that is where your inverters are put together in a daisy chain. Okay, so the most important information, as you can see there with this box below our diagram here, is that the only terminal that can connect in parallel is the grid terminal. Okay, only the grid terminal, which is D, can connect in parallel. You can't parallel backup terminals. That is why you see our backup terminals, each backup goes to its own load. Each backup goes to its own load. There is no saying, let me take power from this inverter's backup and power from that and power from that and link them together. You can't do that. So the backup terminal cannot be put in parallel. The battery terminal cannot also be put in parallel. It's only the grid that can be put in parallel. Okay? Then there's a situation where, for example, I think last week we have been discussing, if you remember well, last week we have been discussing our what was that? The CX range, which is your grid tied inverters. So there's a situation where you already have a grid tied inverter, right? and you decide that I want to add some storage. Remember, storage doesn't work with the grid-tied inverter, right? So what you want to do this time around is to say, okay, now if there's no power, I want something that will work when there's no power, unlike the CX range, which is a grid-tied system, right? So we call that retrofitting, right? In other words, you're putting in a new system to work with an old system that was in existence before. All right. So what you do is you add a hybrid inverter to a grid connected inverter. Obviously, if the existing system that you had is a three-phase system, you then have to choose a three-phase inverter. In this case, it's a Tenarity. If it's a single-phase system, you have to choose a single-phase inverter, which is the 6RS. You cannot mix up to say you put in a single phase with with a three-phase system that was already installed before. Okay, so before your system is installed, before you do retrofitting, we assume that you already have a power inverter with your AC connected to the grid and your power meter connected to the grid there. What you don't have is this part here with the Tenarity inverter. All right. So after you've connected that part with the hybrid inverter, the hybrid inverter will manage your energy as we saw before. All right. That will result in self consumption. All right. It will actually improve your self consumption because now you have got storage. If you produce excess, you have got somewhere to store it. It's unlike a situation that you had before you put in a hybrid system where you could just produce excess power and maybe you just decide to do nothing with it or export it to the grid. So in a situation like this where you have got an on-grid port to retrofit an existing system, what happens is your AC terminal of this grid-tied inverter and the grid terminal of the hybrid inverter, you connect them in parallel. Okay, because you're producing power from two different sources. All right, this grid-tied inverter, this hybrid inverter, you can either use it with panels or without panels. That is why you've got an optional connection. They were saying panels can or may not be connected. All right, so this connection, what will happen is your main inverter, which is written PV inverter, they will be charging the batteries through your hybrid inverter and the batteries will be filling up. That is in the case where you don't have these panels here installed to the hybrid inverter. All right. Once the batteries are full, this inverter will do frequency shifting to communicate with the PV inverter to tell it that the batteries are full, and then it will stop bringing power this side. If power goes on the grid side, it means this side, the AC side of the PV inverter, does not work because remember it depends on the grid. And then this smaller Tenarity will take over and run your essential loads. That is the point of having a retrofitted system. All right, this situation that we had here, it's an on-grid. Okay, you can have an off-grid system, an off-grid kind of setup with the off-grid port. You can still see this is still our PV inverter. This is our Tenarity or the 6RS. The connection is still the same, right? But the difference now what we are trying to do is to maximize the use of PV energy by allowing the PV inverter to work even when in off-grid. Before, we wanted to maximize self-consumption, right? That is what we wanted to do. But here, we are saying we want to maximize the use of PV energy by allowing the inverter to work even when it's off-grid. Okay, so you take the AC terminal of the PV inverter, which is this, then you link it up to the backup part of the hybrid inverter, right? Remember, you shouldn't have power from the main inverter that exceeds the nominal power of the hybrid. It's very important to check that, right? So the difference in this situation with the previous one is here you have taken the AC power, it goes directly to the backup. But before, it was going to the grid link, right? This was going to the grid link. But here, it goes to the backup link. So that this system can still operate even when there is no grid. Remember this one, we said once the grid is gone, this whole part will not operate. This whole part doesn't operate. But with this situation, even if the grid goes, I think you can see that this system doesn't depend on the grid. Okay, so that is what we say retrofitting. So there's a retrofitting for on-grid and retrofitting for off-grid. And both these inverters, they support that. Just remember that one is three-phase and the other is single phase. So depending on what you have to choose the right one. And here's the terminal description of our inverter. There you can see your PV terminals, 1, and you can see a battery connection on number 2 there where you put in your SBR batteries, and then your WLAN connection there, your LAN terminal, you put it there. You also have your COM terminal number 6 there, which is the communications. Then you have your backup terminal. This is where you put up that's where you put your backup loads, right? And then the grid terminal, that is where you put up your ESCOM there, right? The comms has quite a number of things that you can put there. Remember, A1, B1 is reserved for linking inverters in a daisy chain. A2, B2 is for connecting the meter. Okay, and depending on what kind of storage you have, you can use your CAN bus to connect the batteries. As you heard from the video, if you're using LG batteries, they normally use that other terminal there. Right, as this is what I was explaining just now, to say your meter goes to A2, B2, your RS485 A1, B1 is for linking the inverters. But if you're using an LG a lithium ion battery, you can use these parts as well. So you can actually use those functions for your benefit, depending on what you have exactly. Right. So the 6RS has got what we call potential induced degradation recovery function, or PID recovery function, right? Whereby, remember with time, when your panels are working, especially if they are P-type, right? They are P-type panels. They are affected by a degradation in terms of how much power they can generate over time. Okay, so the 6RS has got a function to reverse that process of the aging of the panel, or to make it slower than it normally would. All right. So, like I'm saying, the PID recovery function only operates or applies to P-type panels. Right. So when you enable it on the inverter, what happens is there will be a potential that rises between the negative pole of the PV of a P-type panel and the ground in order to recover. I think you can see here this connection that you've got your PV string connected to the inverter, and then your battery, and then the grid, right? So it will raise the potential between the negative pole of the PV array and the earth. That is normally done at night when there is no power. Okay, so it will actually send back power to the panels at night in order to reverse the process of PID. So it's very, very important to make use of that function because it sort of helps you to reduce the aging process of your panels. But of course, it's very important for you also to check if your panels are P-type or they are N-type. Right, so this is the end of our presentation. I would like to leave time for any questions. If we have any questions, we can then address them. There's quite a number of things that we spoke about. Of course, this presentation is just the introduction. There's going to be a series of other presentations that will be coming on the same product. But this is just a starting point for us to understand the direction or the innovation behind all these products. We will have more and more presentations that will go on as we have prepared on our calendar that you will soon be attending. But at least for now, you've got an idea of what you should be considering in terms of procurement, what works for the projects that you want to do. If you already had a client with a grid-tied inverter who is now complaining about load shedding, who needs, a system to be upgraded to be more like a retrofitted kind of system, this is where the hybrid inverters come in. Or if you just want to make a new installation, you can still use these hybrid inverters. Okay, I'll leave time to my colleagues if there's anything they want to say.
Eden, I have a quick question for you.
Yeah.
How many hybrid inverters would you be able to put in parallel?
All right, so I think I showed that the Tenarities you can put about 5 in parallel. Yeah, there's a maximum of 5.
Perfect. Thank you.
Yeah, and they have to be the same type. Remember, you can't put the Tenarity with the 6RS because they're actually different in terms of their operation. One is single phase, the other is 3-phase.
Yes. And
Yeah.
if you would want to run multiple battery units on that, would you connect a battery unit to each one of the hybrid inverters?
Yeah. So each inverter, like I said before, when they are put in parallel to each other, the only thing that connects in parallel is the grid terminal. All right. Storage has to be, each inverter must have its own storage. And the backup loads, each inverter must have its own backup load. You can't put backup loads in parallel. You can't put storage in parallel to work with those inverters.
Awesome. Thank you so much.
Oh.
Thank you, guys. I think that's it for today's training session. We'll definitely send out more communications with our next ones coming up. But thank you for joining, and have a good weekend.
Thank you, Daniel.
Thank you, Eden.